Hear the groans of joy, the quadratic formula. Jacob lied. Either that or maybe he was joking with himself so he can chuckle now. All right, can I have your attention up here? Okay, thank you. So I know that, eyes and ears right here. I know that the majority of you, well, I'm hoping everyone remembers about the quadratic formula. You may not remember the quadratic formula. If you remember it, tell your neighbor real quick what it is. Page 60 of your student journal, if you haven't already done so, it's at the bottom you can see the quadratic formula. X is equal to opposite of b plus or minus square root of b squared minus 4ac all over 2a. Now there are some teachers that will be creative and sing to you about it, but I will not do that. All right? And you can count that you're welcome, you know. All right, but what we will do is we're going to derive the formula. So contrary to popular belief by some students, quadratic formula was not invented by Mr. or Miss Quadratic. Okay? There are actually mathematical way we came up with it. I didn't come up with it. So, sorry. But we're going to go through it. So, let's say we're given standard form here. All right. We're going to go through this fairly fast, but tell your neighbor, really quick, what they did to get from here to here. Okay, Kai, what'd they do? Subtracted C from both sides. All right. Kind of like a proof, yes. Good idea. Well, think about it. Okay? All right. What did we do from here to here? Divide by A. Well done. Okay, getting a little tougher. What did we do from here to here? Tell your neighbor. Okay, volunteer, what did we do? Okay, maybe to make it easier, what did they do from here to here? And then from here to here? Good. They added b over 2a quantity squared. Now, sorry, why did they do that? Yeah. It is axis symmetry. That's not why they did it, though. At least b opposite of b over 2a is axis symmetry. Okay? They took, maybe this will help, they took half of this term and squared it. When do we take half of that term and square it? What's that? What'd you say? Yeah, completing the square, right? They're completing the square. They're making a perfect square trinomial right here. You take half of b, your b term, and square it to get a perfect square trinomial. Okay, so they added b squared over 2a to each side to end up with a perfect square. Some of you call that completing the square. Okay? All right, so now what do they do from here to here? Oh, this is where it gets a little more complex. I don't want people shutting down. They're like, oh, that looks too hard, so I'm done. I'm going to bow out. Yeah? Okay, well, did this side change? Did this side change? What happened? Okay, so they actually simplified here, right? They actually carried out the square. And they multiplied by what, Derek? Yes, they multiplied by 4a. They found a common denominator. Okay? They found a common denominator. Now, why would you find a common denominator? What's that? Yeah, the reason you find a common denominator is to add fractions. So, might be something to look at on the next step there. What did they do on this side? Hold on. When we go from a trinomial to a binomial, what's that called? That's called factoring. They factored it. They actually did the factoring. What did they do here? Okay, they factored, and here they combine like terms. Can't believe some of you want to do this every time. That's awesome. Okay? And now what did they do from here to here? Yeah, they took the square root from both sides. Took the square root of each side. All right, and then good. They subtracted b over 2a from both sides. And finally, they simplified, or they added the two fractions. Combine like terms, or however you want to put it. I'm going to just say added fractions. Just people trying to solve for that. I don't know who actually. Okay, isn't that awesome? And now we have the quadratic formula. That's totally quadratical. Huh? You like it? That's good. Okay, go ahead and turn to page 61 of your student journal. Okay. 1 or A through F. Off you go. Here we go. Numbers A, or letters A and B. And I'm going to make a quick reference on B here. A is 3, 1. There's the work. Letter 3, 1 or 1, 3. Okay? Compare your work if you missed it. The most common mistake happens right in here. Bless you. Allergic to quadratics. That's not good. Okay, negative 1 times 3 times, or 1 times 3. Negative 4 times 1 times 3 is 12. Or negative 12. Which makes 16 minus 12, or 4. Okay, now, on letter B, when you're dividing each term by 2 here, this has a 2, that has a 2, you can think of it as 2 over 2 plus minus 2i over 2. This part becomes 1, and this part becomes just I. The 2's cancel. Okay? 1 plus minus I. What's that? I'll come over and check it out. All right, let's go move on. You're on now C and D. If you already finished C and D, move to E and F. I'll put the next ones up here in a minute or so. How wrong am I? All right, letter C and D. Well, if you only have one done, correct that one. Yay. I hope you did. Now, when you get to the root of 0, that is 0, our hero. Okay? Oh, yeah. All right. Make sure you're asking if you need help. Final 2 problems. All right. Last 2. No, it's about a minute and a half. There they are. Get some eyes there. Hey, see the answer? There are two eyes up there. Get it? Yeah. Some of the problems that happen when we start using our calculator, you're going to start getting weird error messages when you have negatives. Okay? Like it'll just say error, or it'll say invalid. Yeah, I don't. You get some kind of weird messages. Usually it's just an error message, but depending on what type of calculator you're using there. This gives you, whenever you have that negative, you're going to have to calculate that out by hand. And remember, you pull that I out, or that -1 out to make I. All right. Remember right here, this is another one of those situations where you can do that canceling. 2 divided by 2 and -4 divided by 2. Any questions? Okay, so we have 5 different methods that we've studied this chapter to solve quadratics. What's one of them? Factoring's one. What's another? Square roots and completing the square. So now we have 3. Quadratic formula is 4. Graphing is the 5th one. So all 5 of those methods. Okay? Now, in your textbook, if you really want to reference it, I'm not going to have you copy this down, but this would be in section 3-4, pages 121 to 130 there. These are your methods. Okay? And when to use them. The good thing about the quadratic formula is it can be used for any quadratic equation. Whereas factoring, it has to be an equation that you can factor. And completing or using square roots, you don't want to have a b term. Okay? But quadratic formula you can use for any of them. Okay? All right. Yeah. Well, because there's quicker ways. Yep. Okay. Yeah. It's a good question. Will you be required to use a specific method? There on your tests and quizzes, I might ask for you to just use completing the square or factor or graphing. You guys have your quiz tomorrow, so be prepared to utilize any of those methods. Except for tomorrow on your quiz, the quadratic formula is not on it. We just took an extra day. But if you want to use it on it, you can, unless I specify otherwise. Yes? I want to go through the discriminant really quick. The discriminant helps us determine how many real zeros there are. Okay? So when you're dealing with the quadratic formula, if you think, this is on page 63 of your student journal, by the way. Okay, so we have our quadratic formula. The area that we're going to focus on that's causing all the fun joy for us this chapter is this area right under the radical. That thing right there. That b squared minus 4ac is called your discriminant. Okay? The discriminant tells you how many zeros there are. So for instance, if I had that and I was doing opposite of b plus or minus square root of, let's say I had 0 under there. So the b squared minus 4ac now has become 0. Okay? All over 2a. Okay? What ends up happening here, what's the square root of 0? 0. So this whole part disappears and I'm left with negative b over 2a, which is one real solution. Okay? It does. So what I'm trying to do, rather than just saying, hey, here you go, I'm trying to explain it to you why it is. That way when your friend comes up to you and says, hey, why is it like that? Like, I know it says that, but why is it? You can actually explain it. Okay? And hopefully conceptually understand it a little more. Then again, if you don't want to know, then you just memorize it. That's cool. Okay? So if your b squared minus 4ac equals 0, there you got it. What if your b squared minus 4ac is equal to a negative? Yes, we could look up here and we could say, well, here's our 0. Which one of these is a negative? Yeah, this one right here. It's negative, right? It's less than 0. Okay, if it's equal to a negative, notice in your quadratic formula you would end up, that's an A, you'd end up with that thing right there. You'd have a negative symbol right there. And what's the root of a negative? Yeah, it's a complex number, or it's an imaginary number. Thank you. It's an imaginary number, which means you don't have any real solutions. You would end up with a root. You'd have opposite of b plus or minus, and then you'd have the I over there. Maybe I root something. Okay, but you'd have I. This means you have no real solutions. Okay, you'd have imaginary solutions. Why I keep on saying. Okay, which also means that my graph never crosses the x-axis. Whereas when I had one solution, my discriminant was 0, it crossed one place. So the last one is when b squared minus 4ac is positive. It's greater than 0. And when that happens, that's the one that you're most familiar with. Get a positive number in there, which means you have opposite of b plus or minus square root of a positive. Could be a whole number. We don't know. But that gives you two real solutions. Yeah, I know I did. But I'm trying to point out what it actually gives you. I mean, it doesn't simplify, right? It becomes the same thing. Okay, or I guess you could simplify the radical there, possibly. We'll see. You never know what it is until we actually plug in our ABC. All right. So notice in all of these, did I include the square root symbol? For b squared minus 4ac, do I have a square root on it? No. Your discriminant does not include the square root. It's what's underneath the radical symbol. Okay. Any questions there? All right. Hey, one last thing before you guys get going today. Okay, I want you to complete, if I can find it, one problem here I want you to do. There you go. Now that you've read through that, back earlier in the chapter, we talked about, this is on page 126 of your textbook if you want to reference it later, but we talked about this function, h equals negative 16t squared plus our initial height, h sub 0, okay, where that's when an object is dropped. Okay, we're just standing at a building and we drop it off the building. Okay? When we actually throw something, which is happening in this problem, it's launched or thrown up in the air, you have to add a velocity to that. Okay? And so that's what the v is. So we have our height is equal to negative 16t squared plus our initial height, but then we also have our initial velocity times t. This is page 126. Sorry, I'm trying to zoom in so you guys can see it. Yeah.
So wouldn't that be the same as the b value?
Yes. The b. Yes.
Okay.
The v would be the same thing as the b term.
Yeah.
Yes. Yes. Sorry, I was making sure you had that. That made it blurry. I don't know what's up with that. There we go. All right. Good? All right. Now you can go ahead and try to finish up your problem. Let me put the whole thing on the screen for you. There you go. For those of you that need a starting point, once we have our formula, maybe after we plug all the pieces, how many plugged all those pieces in? The 30 and the 4. Okay? So from there, we should set our height equal to 3. Now understand when time is 0, the height of our object is what?
4.
Okay, when time is 0, the height of our object is 4. Okay, so if you're thinking about it, at time 0, at time 0, you are throwing the ball up into the air, okay, at a height of 4. So you have, let me try to draw a quick sketch. Be really, okay, so you have here, you have a height 4, this is you, and at time 0, you toss the ball up in the air. And now the question is, when does the ball fall back to a height of 3? So here's 4, say here's 3, obviously not to scale, but when is it back to that point? How long is the ball in the air before it gets to a height of 3? Okay, that's the question. So if we set our height equal to 3, and off you go solving it. If you can't factor, you have a bunch of different ways to solve it now. I always try factoring first if there's a b term, but if that doesn't work, use your quadratic formula or graphing or one of those things. All right, I'm going to zoom into the work here. Now, I used the quadratic formula, and I ended up with 2 different answers. Approximately negative 0.33333, 0.0333. Well, that can't be negative, right? You can't have a negative time. And then approximately 1.9 seconds, which is the correct answer. The ball is in the air about 1.9 seconds. All right. How many got it? How many are right on the way? You're like on the cusp of getting it. Okay. All right. Don't want tears. Hey, your assignment today is the student journal. Page 64. Okay, now please keep in mind this is due on when? This is due Thursday or Wednesday because tomorrow is your quiz. So your main focus, if you haven't done so already, better be on your pre-quiz. Okay? But answers are on the board. Very good.